This is 3.8. It's the last section in the polynomial chapter. So this question says, find the local maxima and minima of the given graph. So, hold on a second, let me do this. If I had a quadratic equation that drew a parabola like this, that would be called the minimum. That is the lowest point. And if I had an upside down parabola, then that would be the maximum. Okay? But sometimes we have more than one wiggle, and so we have these special points, some of which will be termed either a maximum or a minimum. Like this one is the maximum. The graph never gets higher than y equals 3. But these other 2 points are also important. So instead of calling them maximums and minimums, we call them local maximums and minimums. And that means that near that point, nothing is higher than 2. And near this point, nothing is lower than -3. So that concept is pretty simple. So all local maximum values of h. So what are the local maximum values? Well, 2 and 3. Piece of cake, right? All values which h has a local, okay. So this is kind of tricky. All local maximum values of h. So this function's name is h, and it wants to know how high does h get? So the answer is 2 and 3. And then B is a little bit different. It says all values at which h has a local maximum. That's the x value. So this says what are the highest points, and this says which x values create the highest points. So that would be 4 and -2. Okay, let's do another one. Okay, all local minimums. Well, there's only one minimum at y equals 0. And then which values create a local minimum? That would be x equals -3. Does that make sense? So we need to know what are the maximums and the minimums, and what numbers create the maximums and minimums. Okay. All right. Here we have a quadratic, -2x squared minus 7x minus 2, and it wants us to use a graphing calculator to figure out what the roots are. So I'm going to pull up my TI-84, and I'm going to go into y equals, and clear out any equation you have, and then just type that in. Now, this is kind of tricky. You see a minus symbol and a minus symbol and a minus symbol, but one of them is a negative. And these calculators differentiate between subtraction, which is here, and negative, which is there. So how do you know which button you're supposed to use? It turns out you already know. You just don't realize it. Read the problem out loud. -2x squared minus 7x minus 2. If you say negative, use the negative button. If you say minus or subtract, then use the subtraction button. So -2, and then the x button is right here next to the green button. X squared minus 7x minus 2. And then I'm going to graph it. Oh, hold on a second. Let's say my graph looks weird. Okay. How do I get back to the regular graphing screen? You push zoom and then number 6 for standard. So zoom 6. Okay. So it doesn't look like those are very nice numbers. How do I find the roots if they're not nice numbers? Well, we could just move the arrow over. So is it going to be -0.378? Probably not. You could also push trace, which will snap it to the graph and get as close as I can. Is that going to be the correct answer? No. How do I know that's not the correct answer? The y value is not 0. Okay? So if you push trace, you can type numbers in. So let's try negative 0.4. Nope. So I need something smaller. Negative 0.3. Oh, that's really close. But this is going to be a terrible game. We don't want to play this game. So instead, right above trace, you see calc. Push second calc. And then we want to find the zeros. So push 2. And now I need to pick some number to the left. And then some number to the right. And I need to make sure, is my answer sandwiched between those two arrows? Yes. And then it says guess, get as close as you can, and hit enter. And I need to round this to the nearest hundredth, so it'd be negative 0.31. Okay, is anybody having any problem with their calculator? Anything you need me to fix for you? Okay, now you don't have to use the arrow keys to find the roots. So let's find the other one, second calc value. And it looks like the answer is negative 3. So if I don't want it pushed over clear to here, you can just pick a number to the left. So I'm going to type in negative 4. And sometimes that will save you a lot of time. And then for my right bound, I'm going to guess negative 2. And then for my guess, I will put negative 3. Okay, now, I was hoping this would happen. That's not 0. So is that the correct answer? Well, yeah. What is this number? What happens when we do negative 1 times 10 to the negative 12? I need to move the decimal 12 places to the left. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12. So the y value is 0.000001, which is actually really, really close to 0. So if you see something funny like this happen, just know that that's a 0. Another thing that you might see is, let's say the answer is exactly negative 3. Well, sometimes the calculator will pretend that it's really smart and it will say negative 3.000000001. It means negative 3. Or 2.999999996. That means 3. So every once in a while the calculator messes up. It thinks it's really smart and it's not. Okay. So how do we do this with the ALEKS calculator? All right. So we turn on. Uh-oh. I can't see the whole. This is a problem. Oh, that's just wonderful. I wonder if I can zoom out. There we go. Okay, so I had to zoom out in order to see it. All right, y equals. So, negative 2x. Where's the squared button? No, that's summation right here. To the second minus 7x minus 2. Okay. So I have that same graph. I want to find the roots. So I'm going to push calc. Nope. Graph. Zeros. So left bound, negative 1. Right bound, 1. Find the 0. There we go. Okay, and then to find the other one, left bound, negative 4. Right bound, negative 2. And then find the 0. So this one would be 31.8 or 3.19. because we'd have to round that 8 up to a 9. Okay. All right. So now we have a large polynomial and we want to find all of the local minimums and maximums. So I pull up this calculator and negative 4x raised to the 4th plus 2x to the 3rd minus 8x squared minus 5x plus 2. Then I graph it. Really? That's it? Did I mess up? Negative 4. Oh, how about 4x to the 4th plus 2x minus 8x squared minus 5x plus 2. All right, that's a little more interesting. All right, I'm going to zoom in because I can't see that very well. Now I want to go up, so I'm going to go into my window and I'm going to change my y maximum. Let's go up to 4. Now, then I need to change my y minimum. Let's go down to negative 5. And then I'll be able to see the graph a little bit easier. Okay, so this has one local maximum and 2 local minimums. And this wants me to, we want to find the local maximums. Okay, so this graph only has 1. So I want to find this point right here. So I go second calc, and I choose maximum, which is 4. And then I need to do my left bound and my right bound and my guess. So for a left bound, I'm going to choose negative 1. For my right bound, I'm going to choose 0. And the answer I'm looking for is between those 2 marks. So for my guess, I'm going to go right there. Okay, and it says, what is the point? The x value is negative 0.3. And the f of x value, also known as the y value, is 2.76. So negative 0.3 comma 2.76. And if there are 2 maximums, then you would write 2 different answers. But anyway, this one only has 1. So let's do the same thing with the ALEKS calculator. So we need a new function. 4x. I wonder if it will let me do this. Oh, it's not letting me type at all. 4x to the 4th plus 2x to the 3rd minus 8x squared minus 5x plus 2. Okay, push graph. And then if I want to, I can zoom in again, find that value right there. Okay, so we want extrema. So, this doesn't differentiate between maximums and minimums. We'll see how this goes. So left bound, I'll say negative 1. Right bound, I will say 0. And it says the minimum is negative 1, 1, which doesn't make any sense because I want to find the maximum. So the maximum is negative 0.3 and 2.76. Okay, everybody understand that? All right. Same basic idea here, but now it's a cubic equation, so it can have 3 answers. So if I type this in, negative x to the third plus 2x squared plus 3x minus 3, and then I push graph. So now I have to find 3 roots. So I would do left bound, right bound, guess, left bound, right bound, guess, left bound, right bound, guess. And you'd find all of them that way. Okay. All right, matching graphs with polynomials. Okay. You could just type this in your calculator and graph it, but there's actually a much easier way. So how many x's does this have? 3. And it's a positive, so it has to look like this, right? And it has a root at -3, and then this factors into x minus 1 and x plus 1. I'm not very good at drawing with my mouse. So I know that the roots are -3, -1, and +1. So all I have to do is find the graph that matches that. -3, -1, and +1. Make sense? Okay. Let's. I don't need the calculator anymore. So, excuse me. So let's factor this. I'm going to pull out an x to the third, a 2x to the third, and then I get x plus 3. So I know this one, it's a w because it's an x to the fourth. And I know it hits at x equals 0, and again at x equals -3. Right? But it actually hits 0 3 times. So if I had x plus 2, then that would hit the graph at -2. But what if it was x plus 2 squared? How do you hit -2 twice? It bounce off. So that would be a bounce. But what if it was a third power? Then it does the x to the third saddle. It comes up and flattens out and then goes up again. And it hits right here at -2. So this w, it's going to hit at -3, and it's going to do the weird saddle at 0. So -3 and 0. So we come down and we do a saddle, and then we go through 0. So we would need to find the graph that looked like that. Okay. What if I had x minus 2, let's do x plus 1 squared, the -3 out front, and x minus 4 to the third. How many x's are there? 5. And there's a negative out front, so what are the endpoints going to look like? Up or down? Well, the left side will be up, and the right side will be down. So it has to look like this. And what happens in the middle? Well, we're going to have a bounce at -1, and we're going to have a saddle at 4. So we come down, and we bounce off -1, and then we have a saddle at 4. Like that. All right. Okay. So all of those problems are pretty easy. The last one is the tricky one. All right. Let's imagine this is a roller coaster. And you always travel in your roller coaster. So So here's our roller coaster. Anyway, a whole bunch of wheels. We always travel from left to right. We are going to look at specific instances of what's going on in that roller coaster. So we want to pay attention to things like, is the roller coaster going downhill? Is it going uphill? Is it flat? What's the highest it reaches? What's the lowest it reaches? That kind of thing. So when we start, the roller coaster is obviously going downhill, right? Are there any other places where the roller coaster is going downhill? So it's going downhill from here to here, and also from here to here. Okay, those are called decreasing. And we're not so much concerned with how far the roller coaster drops. We just want to know when in time is the roller coaster going down the hill. So right now is 0, right? This instant is 0. So when was the roller coaster going down the hill in the past? Well, we know it stops going downhill at -5 seconds, right? When did it start going down the hill? Forever ago, right? We suspect that this graph is not going to turn around and come back down. So decreasing is x is equal to -infinity to -5. Okay, now these are intervals, they're not points. And we have to choose, do we use a bracket, which means equal to, or a parenthesis, which means not equal to? Well, can you ever equal infinity? No. So infinity always gets a parenthesis. Is the roller coaster going down the hill at -5? What's happening at -5? It's totally flat, right? Well, I guess the whole roller coaster can't be flat, but you are traveling horizontally. Does that make sense? So once we hit -5, we are flat. So should we put a parenthesis or a bracket on -5? Parenthesis. Okay. Now, there is another moment in time when the roller coaster is going downhill. So we're going to write the union symbol. And when does the roller coaster start going downhill? At 1. And when does it stop going downhill? At 6. Okay. How about increasing? When are you going uphill? From -5 to 1. And neither of those are equal to, because at -5 and at 1, you are flat. Right? When you crest that hill, or when you get to the bottom of a hill, then you are going perfectly flat just for that one instant. And then union with, when else is the roller coaster going uphill? 6 to infinity. Now, remember, none of those are y values. Those are all x values. We're not asking how high the roller coaster went. We just want to know when in time were you going downhill, and when in time were you going uphill. Okay. So if we look at this, so over which intervals is the function increasing? And then which x values does the function have a local minima? So you're just going to say which x's create minimums. So if we look there, which x values create minimums? -5 and 6. And then what is the sign of the function's leading coefficient? Is this a positive graph or a negative graph? Positive, because it's a w, not an m. And then what could be the degree of the function? 4. Could it be an x to the 6th? Could it be an x to the 5th? No, why not? In an x to the fifth, you would have to have an upside and a downside, right? So if both ends are up or both ends are down, then it has to be even. Could this be an x squared equation? No, because it's a w. But it could be a 4 or a 6 or an 8. Okay, what if I had this graph? Oh, well, hold on a second. What could that graph be? It could be a 7 or a 9. Why not a 5? We hit the x-axis 1, 2, 3, 4, 5, 6, 7 times. So it has to be at least an x to the 7th. And because the ends are in different directions, it can't be even. So that could be a 7 or a 9. All right. 3.8. Go for it.